All right, a ball is yeah, I should have just kept going with the lesson with them on speakerphone. A ball is thrown from the top of one building towards a tall building 50 meters away. The initial velocity of the ball is 20 meters per second at a 40-degree angle above horizontal. How far above or below is the original? So when I draw this, I'm launching from a building, and I'm going to hit another building, and they gave me what kind of distance do they give us? And so this is what I was telling you. When the time that it hits the ground was a vertical issue, but the time that this crosses 50 meters this way, is that a vertical issue this time? No. Okay, so we're going 50 meters this way. It's actually a horizontal issue when it hits the wall. And we don't know if this gets launched up into this gap. Well, we do know it gets launched up into this gap. We know it gets launched at 20 meters per second at an angle of 40 degrees. But we don't know if it lands and keeps going and hits up here. Or maybe it falls into the gap down here. And so they put it on a building just so you wouldn't know, okay? That way it doesn't just hit the ground, okay? If it hit the ground, it'd be a totally separate problem. We're going to go into the gap between the two buildings, and I don't know if it hits above or below where I started. We do know... Wait, what do we know? That's pretty much it. Did they tell us anything else? Okay, so we said that it would be a horizontal issue to find the time, though. The other thing that gives it away that it's a horizontal issue to find the time is that if I were to chart this out, we would have X, we would have VI, VF, A, T. This would be negative 9.8 if we're talking about a vertical. But in our horizontal, we only need 2 of the 3 parts, right? And we have the fact that the VI is 20 cosine 40, and we have the fact that it is 50 meters away. So it's almost like I have 2, technically 3 pieces to solve any part. That A just tells me that I'm going to use X equals VT. I have the V. I have the X. I can solve for T. Our bridge portion of it. So 20 cosine 40, we could solve for that. Calculator. 20. No. What do I need? Trig. Cosine. I don't need that squared. 40. 20 cosine 40. Degree mode. 15.32. And so we're going to cross 50 meters with a speed of 15.32 meters per second. So really I would just take my X and divide by V to get my T. So 50 divided by 15.32 equals 3.26 seconds. VI is going to be 20 sine 40. And I already solved for it right here in my calculator. That's 12.8558. 12.86 meters per second. I have my time, 3.26 seconds. I've got a lot of information to find my X. Let me go back and show a little bit of work. I have 15.32 and 50 equals T. So T equaled 3.26. Now I have X equals V I T plus 1/2 AT squared. And I've got 12.86 times T 3.26 plus 1/2 negative 9.8. 3.26 squared. Take a second. Make sure that you have all your negatives. Does VI need a negative? No, it's launched up. T, time. We're not moving back in time. Negative 9.8, that's true. So this whole positive term means I get launched up and I would be moving forward and up. But then this means that after time, I'm going to take away how fast I'm moving from it, which makes sense. When I get my answer, x equals negative, I think it's like negative 10 point, I don't know. I don't have my previous notes in front of me. 1.5? So my x is 10.15 meters. So I ended up on this pink dot right here. I ended up below where I started from, not above. Okay? That makes sense because after the first second, I'd still be moving up, but after a third of that second, I'd be at a 0 speed-ish, and then I'd start moving down. So about 1.3 seconds in, I'm actually moving down.